Hey, hi. In this video, we're going to do a lab session on Amazon Bedrock base model provided by provider called Meta. So if you go to the Amazon Bedrock page, currently I'm in my AWS account and I'm in Oregon region. So in this Oregon region, I went to Amazon Bedrock service and then I'm in base model. In the base model, I'm going to select a provider called Meta, which is Meta AI, right? So this Meta AI is providing four base models, namely called Llama. That is, so as you see here, there are four variants of Llama 2 models specialized for particular purpose. So if I can tell you in a layman term, the top two Llama 2 modules um, are dedicated for text generation and conversation purpose, and the below two are meant for text generation, specialized for chat optimization type of conversations. All right, so here what I do is I'm going to show you in a two things. First, let's explore more about what is Llama 2 all about, and then we're going to see how to use this Llama 2 module with using Python. In the sense, we try to invoke the this model with using Python APIs provided by Amazon Bedrock, right? So here, so to talk more about this, okay, so basically this Llama 2 model is been grown by or developed by Meta AI, right? And it is a text model, and it has a capability of 4096 token context. In the sense, context length, this token context length can be up to 4096, which is looks to be one of the the topmost in the market. Yeah, and so Llama 2 is a high performance auto regressive language model designed for developers. It is used to optimized. So if you see the description, right, that's what I'm reading here. So it is used an optimized transformer architecture and pre-trained model, and are trained on 2 trillion tokens. Okay, that is massively, that's basically very massive. In the sense, what does that mean is, this model is been trained, in the sense it has been it has been now intelligent with the training of 2 trillion tokens, which is actually very high, right? So this model is being now being provided as open source, and it also available in Amazon Bedrock for enterprise consumption as well. So what we do is, before I show you like how to invoke the this model from Python APIs, and which eventually helps you to integrate with the in your applications, let's see more details about the Llama 2 first. Then we're going to go to go to the lab session. That is, we try to explore, in the sense we try to invoke that model and try to realize the values. Yeah. So here, as I said, this model is a large language model. That's the reason it is called as a LLM. But the name of this model is been given by Meta. In the sense, Meta team has grown this, and they have named it as Llama 2, which is basically a version of this previous version was Llama 1. So this is the open source and free for research and commercial users. In the sense, this model is being made as open source so that the the community, right, the community individuals like creators, researchers, and businessmen can take help of this. Yeah. And if you talk more about the technical specifications of this model, which I basically explained just a while ago, so Llama 2 models are trained on 2 trillion tokens, and also have the double context length as of previous version. In the sense, the Llama 1 version was having half of the the token context, but now they have made it as a double, right? And if we go down and try to dig down more about the specifications of Llama 2 model, right? So the model, this Llama 2 model has a three parameter sizes. One is 7b, 13b, and 70b. So in this video, we're going to explore, I'm going to help you to how does this 70b Llama 2 version for conversational AI, or generally called as a generative AI, is helps us to do the job, right? So and the pre-trained, the specifications are trained with 2 trillion tokens, and then the context length is 4096, right? Fine tuned for chat use cases, right? Supervised fine tuning over lakhs, and human preferences over millions, right? And the benchmarks, in the sense, what is this benchmarks? In the sense, the generative AI model has a certain benchmarks, or basically certain metrics through which they are measured for their performance. Okay, so this benchmark table talks about the comparison between the contemporary available generative AI model with the Llama 2 capabilities, right? And whatever you see in the first column is called as a benchmark, as called as a the parameters that measure the performance of your module, right? Which includes MMLU, and then you have trivia QA, natural questions, GSM 8K, human evaluation, AZ evaluation, that is English talk only, Boolean IQ, Hella Swag, Open Book, QA, QC. So basically, till today we have these many benchmarking metrics. In the sense, these metrics are being used to measure the performance of your model, and that is being compared with the existing contemporary AI models, which includes MPT, which is being by Hugging Face, developed in Hugging Face. Then you have a Falcon, Llama 2, right? So Llama 2 is nothing but the current variant of Meta AI. Then you have a MPT, MPT. In the sense, they are comparing with the module called MPT Falcon with the Llama 2. So if you see the Llama 270B, it has the highest the performance, in the sense highest benchmarking ratings. Yeah. So if you compare with the MMLU, you see that the values of this Llama 2 is in highest among all the other contemporary models. Yeah. Or okay, so that's the reason this model is really really outperforming the existing other available modules, right? Now let's see the so how does how does it is helping us to the achieve the safety and helpfulness. Okay, and they are using reinforcement learning from human feedbacks, in the sense, so this is like a mechanism through which they make their model optimized at every cycle. In the sense, somebody uses it and they give the feedback, and with that feedback, this model becomes intelligent again, right? And how does that how does that RLHF, that is reinforcement learning from human feedback, does works in this Llama 2 model is something like this, right? So whatever you see in the left hand bottom, that is pre-training. In the sense, this is the place where the model gets grown and gets trained by the providers, that is Meta AI. So Meta AI have trained this already with the 2 trillion tokens, and it is a self-supervised learning, and it will produce a first version of Llama 2, in the sense like a just out of the manufacturing unit, you can call it like, so that that Llama 2 model, that Llama 2 model is here. Then that will be again supervised fine tuning, in the sense they will have a supervised team which will actually fine tune it again internally, all right? And that is, you see that by basically what is this phase is nothing but the internal team of Meta AI will use that, consume that, and try to fine tune it as much as possible. And here you will have a Llama 2 chart, in the sense this is like a publicly available the endpoint of this model, and then the public will consume it. Here you go, right? So you see that human preferences data, in the sense human will try to consume it, and they will be having a feedbacks after they try to consume it. In the sense, the feedback is like a safety reward model, helpful reward model. In the sense, they will have the feedback whether it is safe, whether it is helpful, like that, right? And that feedback is again acting as an input to the fine tuning. So basically, whatever you see in the right hand is a fine tuning cycle, in the sense as fine tuning the mechanism. And that fine tuning the inputs are coming from the supervised fine tuning plus human feedback, in the sense consumer feedbacks, that you have a simple rejection and you have a proximal policy optimizations. Okay, so those two inputs are being given to this Llama 2 model, and the Llama 2 model is, as you keep on consuming it, it is becoming more intelligent, more fine tuned model. Okay, that is what are all about RLHF. Yeah, I'm going to give you more insight about this RLHF in a dedicated video maybe, right? So basically that's what we saw, that's what this diagram is talks about. Okay, and then it has other further updates like getting started, license, responsible use purpose. And these are like annotations that Meta AI tells the consumers to to align with these points. Yeah. Okay, so with that note, what we do is we're going to jump back to the our main motive, that is how to consume this Meta AI provided Llama 2 model from Bedrock with using Boto 3 APIs. Yeah. So for that case, I have created, or I have got this particular script from the internet. I'm just using it, and there is no much there is no much problem here. So basically, you need to have the You need to have Boto 3 installed in your system. And then I'm going to share this main.py file anyways in the my GitHub repository. The GitHub repository link has been provided in this video's description. You can use it. You can copy that from there and try to experiment, try to integrate in your application like that. Yeah. So here we are actually importing the Boto 3 model. We have a import JSON. We have a Boto core.exception, right? And then this is a very simple function called invoke Llama 2 model. So in this invoke Llama 2 function, invoke Llama 2 function, which is basically invoking the Llama 2 model. It has a two parameters, that is Bedrock runtime client and prompt, on the prompt as well. Prompt is nothing but the question that you want to ask. Like, you might have explored ChatGPT where you type your questions or you type your words, the ChatGPT going to answer you. That's the something same flavor is available here. And if you go to the try and accept block, this is the syntax that you need to carry out. To invoke this model through the Bedrock APIs, you need to have a body, and that body contains four parameters called prompt, temperature, top p, and the maximum generation length. Yeah, so that's the something like this method. These options are from the programmatic side, but if you go back to the UI, you can also find this model. So go to the playground. So here is a playground, and go to the chart, and in the chart you can select the models, right? So select a model. In the select model, let's go to the meta, and meta we're going to use the 70b, that is Llama to chart 70b version. I'm just going to apply, right? So whatever the configuration that you see, right, that is temperature, top p, length, so that configuration, those parameters are being fed in the form of body here in the programmatic. Okay, so I'm gonna show you with the code, and then we're gonna also explore the UI as well. Okay, so this is what the body is all about, and then you need to give a model ID. This is nothing but the consumption of base model in the Amazon Bedrock carries a syntax, right? And that in that syntax has a model ID. So this is like a key that this is like a ID that you need to get it from the you can get it from here as soon as you try to play with this base model, and that would give you a body format, and from there you will have the model ID as well. So in the response, basically now what I do is I'm going to use the Bedrock runtime client. So what is Bedrock runtime client is something which I'm going to show you down the line. So you see that here we are using the Boto 3 model. From that you are creating a client of service called Bedrock runtime, and that will have this is the client. The client is ready. Now to this client, what you are doing is you are invoking a function which is I'm walking you through now, and then it has a model ID. So within this we have a Bedrock client. So this is a Bedrock client being given from here, and Bedrock client plus model ID, and the body has to be given, right? So prompt is nothing but the questions that you're going to ask to this model. In the sense, since this is a text model of generative AI type, in the sense text generative AI basically. Yeah. So this model helps you to generate the text based on the command prompts that you're going to give it to this model, right? And that command is kept in the form of prompts, right? And that is being given while invoking this model. That is, invoke this model of type model ID with this JSON body, right? And then automatically you will get a response, and from the response we are actually reading the body, and from the body we are getting the generation information. In the sense, generation text is been retrieved, and that is been returned. Okay, and it is been, and we are also adding a try catch, basically try exception block as well, right? And finally the result is been given here, right? So what I do is I'm going to tell, like I will ask a questions here saying like explain explain the, okay, let's go with explain. How does, let me see how, okay, I need to use small letter. How does rain, how does rain, very simple question. Okay, so it's for very kids purpose, kids question. Let's say how does it rains. I'm gonna just wait for the answers. So I just click on, in the sense, what is this, how does rain? In the sense, I'm just asking very layman question like how does it rain. Yeah. So even the vocabulary is wrong, but this generative AI model has a intelligence that it identifies the question and tries to give the answers. Okay, currently it is processing, and you see that it has generated the answer, which is nothing but generated the text, and we have answer. You see that answer is rain is formed through the process called water cycle. Water cycle is continuous improvement water, right? Basically that's evaporation will happen, and the cloud will be formed. You see that here is a simplified explanation of the rain formation, right? Evaporation, cloud, and run off, in the sense rain off. Yeah. So that is how the raining will happen, which is actually to the point answer, right? So, and you see that how clearly it is explaining, right? And here we are using, in the sense we are actually interacting with the generative AI model provided by Meta and called as Llama 2 through the programmatic method, that is through the Python. You can use this code in your application and try to build a very intelligent applications, okay, dynamically intelligent applications, right? Now we have seen this in the code. Let's do an experiment from the Bedrock, Amazon Bedrock UI as well. I'm just gonna hit enter, right? So how does it rain? We should see the same answer here. You see that rain forms from the from the precipitations that occurs, right? So basically, it is giving me the answers, yeah, and it is the answer is very clear answers. Okay, for example, say if you are if your kids are sitting in class 2 or class 1, the standard 1 or standard 2 classes, there will be a question called how does rain formation occurs. So in that case, your kid can question to this chat gpt and it will answer. You can copy paste this question in the answer, and he will be getting full marks. All right, so yeah, so this is how basically I have walked you through, like, how does a Meta AI provided generative AI model called Llama 2, which is like massive, in the sense which is being built with the massive configurations, and how does it actually doing the how does it actually generating the AI, how does it is actually generating the text. I know we have experimented with UI, we have experimented with the programmatically, we have also explored its specification, that is technical specifications. All right, so with that note, thank you very much for watching my videos. Kindly please do subscribe my channel, that would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.